that trains your body to fight any foreign agents.
Plants are helpful for the ecosystem.
It's an electronic device for storing and processing data.
The nervous system is all the collection of nerves in your body.
Yeast is a eukaryote.
Welcome to Spectacular Science, where it's all about science, with your host, Akshay.
Hey listeners, welcome back to this episode of Spectacular Science. I'm your host, Akshay. Oh, what a nice and relaxing day at the beach. It's so fun to run around the sand and also to swim in the water. But you know one bad thing about it? I get a lot of salt water in my mouth, and the seawater is just so salty. It's almost like I poured all of my kitchen salt inside the ocean. Well, how did all this salt get here? Because I definitely know it's not a giant salt shaker in the ocean. There has to be something else behind this. That's why I am taking you on a deep dive, literally, into the science of why the ocean is so salty. We'll learn a lot more about salinity and how this affects all the ocean ecosystems in this episode. Let's go! Did you know that 2/3 of the Earth's surface is covered in water? And 97% of that water is salty seawater. Only 3% of our planet's water is fresh, and 2% is trapped in frozen ice caps, glaciers, and soils. That leaves less than 1% as fresh, liquid water in the rivers, lakes, and streams. And this fresh water plays a big role in explaining why the sea is so salty. Let's go back to the water cycle. Water moves around our planet in a cycle powered by the sun, from the sea to the sky to the land and then back to the sea. When the sun heats the water in the sea, it changes into a gas called water vapor and rises into the air through a process called evaporation. While floating in the air, the water vapor cools off and turns back into liquid water, forming clouds through a process called condensation. This water eventually falls from the clouds in the sky as rain, sleet, hail, or snow, and that's called precipitation. When precipitation falls on land, the water flows into streams and rivers and eventually makes its way back out to sea. Then the sun heats the water again and the cycle starts all over again. Now let's go to the precipitation part of it, because we're going to take a dive into something that's called slightly acidic rain. You're probably still wondering where that salt comes from. It definitely doesn't come from a giant salt shaker on a helicopter. Let me tell you that. Well, the rain that falls from the sky is not just pure water. It contains small amounts of chemicals called carbon dioxide and sulfur dioxide, which are absorbed by the water while it's still in the air when it's condensing. This means that rain is actually very slightly acidic, but not enough to do any harm. When the rain falls on the ground, this weak acid can dissolve small amounts of mineral salts from rocks, including the sodium and chloride, which enter the water. Salt, or table salt, is basically sodium chloride, which are the two chemicals that make up it. And those are actually washed down by all these rocks. Sodium chloride is the main salt in seawater, and the same one you might have on your table at home. The rainwater flows off the land and into rivers and streams that lead all the way to the sea, carrying the dissolved salts along with them. So that is how all these salts get in there. It's all of these rocks that get dissolved. But if rivers and streams are carrying these dissolved salts, then why aren't they as salty as the sea? In fact, they're only carrying a very, very, very low levels of salts. The salts in the sea have built up over billions of years, and the seawater contains about 300 times more dissolved salts than the average river water. Salt dissolves easily in water, which means it's able to break down easily in the water and is able to attach to the water molecules. So, there is so much seawater, and only a little bit of that seawater has salt in it. But in fresh water, it's half of that. It's even less concentration of salt. That's why we say that seawater has a much higher concentration of salt, or salinity, than fresh water flowing through streams and rivers. Some salts can also enter the seas from hot vents on the deep ocean floor and from volcanoes on land and in the sea. Some salts, particularly chloride, are moved around part of the water cycle. These salts are known as cyclic salts, and this is all natural. Now, since salt water is always flowing from land to the sea, you might think that the sea is getting saltier. Well, that's not the case. Some of the salt is being removed by algae and animals that live in the sea, and some is deposited as sediment on the bottom of the ocean. So the salts going to the sea keeps a balance with the salt being deposited or removed. The salinity of the water isn't the same everywhere. In warmer tropical areas, more evaporation occurs, so the water is saltier. But towards the north and south poles, the seawater is diluted by melting ice, so the water is not salty. This is all a natural balance. But these differences in salinity might get bigger in the future because of climate change. Warmer climates might lead to more rain and more melting ice in the northern and southern hemispheres, and more evaporation near the equator. And this could change the saltiness of our seas. The saltier the water is, the more dense or heavier it becomes. Along with warmer temperatures, this could affect how water moves around the oceans, which could not just affect all life on our planet, not just the creatures living in the sea. Salt in the ocean has so much impact around the world, and this salinity problem is because of climate change. Now we have to give it up to all the animals that live in these marine environments, because living in salt water is very hard. That is why all these animals have adapted certain ways to survive in these saltwater biomes, and that gives them the ability to survive and eventually reproduce and have an entire species. That is how all these organisms survive. Now, I'm actually going to look into this because it's so cool to see how salinity can change Earth's temperatures and everything. Now, before I go back to my lab with a bunch of seawater samples for studying, let's review what we learned today in this episode. We learned that the oceans are so salty because of runoff water from land. Because the rain is slightly acidic because of all the gases and chemicals in the atmosphere, the rock dissolves slowly and the salts and minerals from those rocks flow into the ocean through rivers and streams. The reason why rivers or streams are not that salty is because they contain a very small amount of salt, while these marine biomes and oceans and seas contain large amounts of salt. Even though there's so much salt in the ocean, it doesn't mean that every time it rains there's more salt going into the ocean. Salt also gets consumed by sea animals and also gets absorbed by many other things. And it can also change depending on the temperature and even about where it is located, such as in the northern hemisphere and near the North Pole, there could be more ice melting, which dilutes the water, which reduces salinity. Because of climate change, more factors are changing the amount of salt in the oceans, and this salt could actually cause many things like changes in weather patterns and in water and how water and marine animals move around the world. That's why it's so important to fight against climate change, and it's so cool to see how all of these things are connected to just one thing: why there's salt in the ocean. It is just amazing to think about it. Thank you so much for listening to this episode of Spectacular Science. Spectacular Science is produced and hosted by me, Akshay J. Raman. Our theme song is by Chayan Ramachandran. Special thanks to Varun Ramachandran. Visit spectacularsci.com to find interactive activities, articles, and blog posts. You can also find all of our episodes and ways to subscribe to this podcast. That's spectacularsci.com. Please subscribe wherever you're listening right now. It really encourages me, and you'll get all the episodes automatically. Thank you so much for all your support. Thanks for listening to this episode, and we'll see you on the next episode of Spectacular Science. Keep thinking about science.